Hello, welcome again. We are solving GATE 2021 Mechanical Engineering Paper 1. Question number 39 is in a grinding operation of a metal, specific energy consumption is 15 joule per mm cube. If the grinding wheel with a diameter of 200 mm is rotating at 3000 rpm to obtain a metal removal rate of 6000 mm cube per minute, then the tangential force on the wheel is dash Newton round up to 2 decimal pieces. Okay. As a specific energy consumption is this 15 joule per mm cube. Okay. And metal removal rate is 6000 mm per minute mm cube per minute or 6000 by 1060 mm cube per second. Okay. And the velocity of cutting is here pi dn by 60. N is your 3000 and D is your 200 mm. Okay. Or we can convert it into meter. So the velocity of cutting is 31.41 meter per second. So these are the data given, and specific energy consumption is nothing but Fc by V, Fc into V divided by metal removal rate. So Fc is your cutting force, V is this quantity, and MRR is your V is this quantity, MRR is this. Okay. So putting the values, so this will be your this is your Fc is your 15 and V is your 31.4. Okay. And this is your MRR is 100. Okay. This is 100. So Fc comes out as 47.75 Newton. Okay, because specific energy consumption in joule per mm cube, so MRR will be taken in mm cube per second and velocity will be taken in meter per second. Okay, so answer is your 47.75 Newton. Okay. Next, a 200 mm wide plate having a thickness of 20 mm is fed through a rolling mill with two rolls. The radius of each roll is 300 mm. The plate thickness is to be reduced to 18 mm in one pass using a roll speed of 50 rpm. The strength coefficient K of the work material flow curve is 300 MPa and the strain hardening exponent N is 0.2. The coefficient of friction between the roll and the plate is 0.1. If the friction is sufficient to permit the rolling operation, then the roll force will be dash kilonewton round up to nearest integer. Okay, so the true strain is final final thickness by initial thickness. Okay, or it is or initial thickness by if it can be taken in negative also. Okay, so it is h naught by hx, okay, initial thickness to final thickness. Okay, so ln 20 by 28 by 18 is your true strain. Okay, actually the true strain is ln lf by li, as width is same, so and volume is constant during plastic deformation, so it comes out as final thickness, sorry, initial thickness by final thickness ln. Okay, so final thickness is, sorry, initial thickness is 20 mm and final thickness is 18, so true strain is 0.1052 and average flow stress is given as sigma in terms of strength coefficient is K true strain with power n divided by 1%. Okay, so this is the average flow stress. This is the way to find out average flow stress in case of plastic deformation. Okay, so as rolling is also the case of plastic deformation, so this can be found out by this. Okay, by K is your strength coefficient. Okay, K is your coefficient, strength coefficient. Okay, so and this is your true strain. So average flow stress is your 159.3. Okay, and the contact length is the contact of roller is the length that is in contact with roller and strip. Okay, so that is given by root r delta h, where r is your radius of roller and delta h is thickness reduced, that is 20 minus 82, and r is your 300. Okay, so this is the contact is 24.49 mm, and the average flow stress is this. Okay, and width is given as 200 mm. Width is 200 mm. Okay, so the area of the contact is 24.99 contact length into width, and the stress is 159.3. So this is your rolling force, that is 780,407 Newton or 780.407 kilonewton. Okay, so the rolling force is that average flow stress into contact area. Okay, and average flow stress will be calculated from this formula, and the strength coefficient is given, and two strength you can find out by ln of initial figure to final figures. Okay. So answer is 780.407 kilonewton. Next, XY table of a NC machine tool is to move from P11 to Q51. All coordinates are in mm. Pitch of the NC drive lead screw is 1 mm. If the backlash between the lead screw and the nut is 1.8 degree, then the total backlash of the table on moving from P to Q is dash mm, round up to 2 decimal places. Okay. Now the backlash in one rotation is given as the backlash is given as 1.8 degree. Okay, so in one rotation it is 1.8 by 360 into 1, because pitch is your, in one rotation the lead screw move by 1 mm, so in 1.8 rotation it will move by this. Okay, so this is the backlash. Okay, now as the table has to move 51 minus 1, that is 50 mm, so in 1 mm the backlash portion is this quantity, so in 50 mm the backlash portion will be 50 to 1.8, 50 multiplied by 360, that is 0.25 mm. Okay, so that is the backlash. Consider a single machine workstation to which job arrive according to a Poisson distribution and with a mean arrival rate 12 job per hour. The process time of the workstation is exponentially distributed with a mean of 4 minutes. The expected number of jobs at the workstation at a given point of time is dash round up to nearest degree. The arrival rate is 12 job per hour, and service rate is as 4 minutes it would take to service one job. Okay, so service rate is 15 job per hour. Okay, so average number of number in system or average number of jobs at the workstation is given by this formula, lambda minus mu by mu minus lambda. So lambda is your 12 and mu is your 15. Putting values you can get 4. Average number of jobs at the workstation is